Hello. We're going to start today talking a little bit more about angles like we talked about last week. This time we're going to talk about a very specific and very important postulate that goes with angles called the angle addition postulate. So we're going to jump right in and talk about what the angle addition postulate says, and we'll go through a couple examples kind of illustrating what this means and how we go about using it. So for the angle addition postulate, if there's a point, like in this case we're saying point D, is in the interior of angle ABC. So basically they're just saying that point D is on the inside of the angle. So here's angle ABC. We're looking at a point that's somewhere inside there. What they're telling you is that the measure of angle ABD, so if we look at ABD, so tracing those letters, A to B to D here, if we take that angle right here and add it to angle DBC, so if we trace those letters, DBC in blue here, when we take these two angles and add them together, so pink plus blue, we get the overall angle, which we had highlighted originally in orange. So adding the two little pieces, pink plus blue, we end up with the big overall piece, orange, angle ABC. So basically this is like the segment addition postulate from a couple weeks ago, where take one little piece plus the other little piece, it equals a bigger piece. So one little angle plus the other little angle equals the bigger angle overall. So when we look at this, to kind of give you guys an example of what this looks like, if we have kind of a similar picture here, some different points and things like that, they're asking us, what two angles do we want to add together to equal to make the big? So basically what we have to do is figure out, well, what are my two small angles in the picture? So here I have one smaller angle, which I could call LMO. So if I take the measure of angle LMO, I have a second small angle here that goes from O to M to N. So if I take those two angles, so the purple plus the green here, if we add those two little angles up, we actually end up with the third big overall angle, which goes from L to M to N. So take one little angle plus the other little angle equals the whole big angle. That's all we're doing with the angle addition. If we throw some measures in here, so same exact main idea, just with finding missing angle measures. So angle WXZ has a measure of 27. So WXZ has a measure of 27, and labeling your picture can help in a lot of these situations. Angle ZXY, so if we highlight angle ZXY here, is 50 degrees. They want us to find the measure of angle WXY, so WXY would be the big overall angle here. So basically what my angle addition postulate says is take one little angle plus the other little angle, and you get the big overall angle. So angle WXY would have to be 77 degrees. So one little plus the other little equals the big. So sometimes it'll be fairly straightforward where we just get numbers, we're adding them together. Other times we might have to do a little bit of a solving an equation idea. So when we're looking at this type of problem here, again, the big thing here is making sure we label the picture correctly. So I might start with the one little angle, PQR. So PQR has a measure of 20 degrees. It also tells me that RQS, so if I trace R to Q to S, has a measure of 2x degrees. And then they tell me that the overall big angle, PQS, let's choose a different PQS here, is this whole big angle here. And they're telling us that that's 3x plus 2. So using my angle addition postulate, I take the two small angles and add them together. So 20 plus 2x has to equal the big angle, 3x plus 2. So now I have an equation that I'm able to solve, so I could subtract 2x from both sides. And that's going to cancel these x's here. I can also subtract 2 from both sides. That's going to cancel the 2's there. So 20 minus 2 is 18. 3x minus 2x is 1x. And so there's my x value for the problem. Now, in some cases, x will be enough. Once you know what x is, you're done, you can quit the problem. Other times, they might ask you to actually find the measures of the missing angles. So they might say, what is the measure of angle RQS? So if that's the case, I need to plug this 18 back in for x. So instead of saying 2x, I would take 2 times 18, and I would get a value of 36 degrees. Or they might say, well, what's the big overall angle? Well, so the big overall angle, again, I could plug in 18, so 3 times 18 plus 2, which would give me 56. Or, since I already knew the two smaller angles, I could have taken 20 plus 36 and gotten the 56. So make sure you pay close attention to the problems. Sometimes you're just finding x and you're done. Other times you need to plug x back in and find the actual angle measure. Angle bisector is a term we need to know, and it's going to be something that we use quite frequently throughout the year. An angle bisector is a ray that divides one angle into two congruent pieces. So in the picture down below here, we have the angle XWZ, and then in the middle of that angle, we have this ray XY or WY. So WY is coming out through the middle here, and note that these two markings here are telling me that the two angles created, these two smaller angles, angle 1 and angle 2 here, are congruent. So those little arc symbols tell us that these two angles here and here are identical. So that means the measure of angle XWY is equal to the measure of angle YWZ. So my two small angles are equal to each other at this point. So when you see angle bisector, they're telling you the two angles or the big angles being cut in half, two congruent smaller angles. So how we use this, if we're told that ray WY here is an angle bisector, and we're told that with the little markings here, then if I go to look at my problem, I can start labeling in pieces, and then I can use that to solve. So ZWY has a measure of 4x plus 2. So Z to W to Y is 4x plus 2. And then they also give me another angle here, XWY. So if I trace those letters, X to W to Y, that's 3x plus 19. Well, since I know that this WY is an angle bisector because of the two markings here, I know that these two angles have to be identical. So I can take 4x plus 2 and set it equal to 3x plus 19. Then I solve my equation, so I can subtract 3x from both sides. That'll cancel my 3x's here. I can subtract 2 from both sides. That'll cancel my 2 there. So 4x minus 3x is x. 19 minus 2 is 17. And there's part of my answer right there. So the first part of the answer said, what is x? Well, we just found that that's 17. If I want to find the actual measure that they're looking for then, so now they want us to find the measure of angle YWX. Well, YWX, if I trace those letters, Y to W to X, we're looking at this angle right here in red. So that angle has this measure, 3x plus 19. Well, since I know what x is now, I can plug that in. So 3 times 17 plus 19. So 3 times 17 is going to be 51, plus 19 is going to be 70. Now that's the only other piece that they needed us to solve for. So we have that YWX is 70. However, if I know that one side is 70 like we just found, that means the other side would also have to be 70 degrees. And then if I needed it, I could find the entire angle measure from x to z here by adding the two pieces. So 70 plus 70 would give me 140. So make sure you pay close attention to the problem. What parts do you need to solve for? Is it just x? Do you need to plug x back in? Do you need to then combine variable or the angles? So make sure you pay close attention there. This should be enough then to work on that worksheet from class, or that you can get off of Google Classroom. As you're working on the worksheet, if you have any questions, make sure you ask. So you can email, you can ask in class, and make sure you double check the answer key to see how you're doing.